go? All right. So, hello, my name is Trevor. I am a software developer. I have been here in Springfield for 7 years. I currently work at Expedia. I've also worked at O'Reilly Auto Parts. I went to school here at Missouri State University, and I studied electronic arts, which is a Bachelor of Science, and my emphasis was video technology. And my minor was actually computer science, but it led me into this great career. So thank you for setting this up and hosting, and thank you all for coming. So first off, I want to just get a show of hands if you think that professional programming should be done with text. All right. Very simple question. Should it be done with text? Raise your hand if you disagree. If you solidly disagree, you think there's a better way to do programming than text. I got two of my friends here in the front. Oh, thanks, guys. All right, and just raise your hands if you're not certain. You just don't know. All right, there we go. So my goal over the next hour is to persuade you that there is a better interface for programming than text. So on today's agenda, I'm going to go over some history of programming interfaces. I'm going to talk about some of the problems that I see in programming today. And then I'm going to talk to you about inspirations I had for a new kind of programming interface. And then I'm going to show you a demo. It's going to be demo time, baby. So my guiding principle in this project is this quote by Linus Torvalds, the creator of Git and Linux. He says, "Bad programmers worry about the code. Good programmers worry about data structures and their relationships." So I'd like to keep that in mind as we go through this. So a brief history of programming, because context is important. Anybody know what you would call this programming language or this type of programming language? I didn't think anybody would know it right off the bat. I'll give you a hint. This is what it looks like. You got it, assembly. Yeah, this is x86 assembly. This is an older form of assembly. This was in the 1940s or 1950s. This was made for like a really old computer called the ARC. So this particular language didn't have a name. It's assembly language. After assembly language, we needed to have a better way to express our ideas for computers to execute. And even when computers were just number crunchers, programs written in early programming languages like Fortran and COBOL had accompanying diagrams like this. And so somebody would make a flowchart, and then another person would go and implement that in code. So this is like the 1960s around then. And that right there, that's a flowchart created by NASA, and I think it's for like computing how much a gas will expand when it combusts or something like that. I didn't go too deep into understanding what that was. After that, in the 1970s, as computers gained more memory and speed, structured languages like ALGOL, and more notably C, used indentation to make visually distinct blocks of code, things that you could move around and show more expressive ideas. So C really set the standard for all future programming languages, as I'm sure you all know. And that led directly into the big boom in Linux, or Unix, excuse me, not Linux. So C was created to facilitate the development of Unix. And in order to do that, we had to have text editors, code editors really, to make C programs. And the two most notable ones I found were Emacs and VI. So this is like the 1970s, 1980s, and mouses weren't really a thing yet, so you had to do everything with the keyboard, and that's what I imagine it feels like to be really good at using VI. At the same time, you had computers being shipped with their own software stack, and you would have programming interfaces that were not just text. So on the left there, that is Smalltalk, and that was created for a machine called the Xerox Alto. And on the right there, that's a programming interface called Turbo Pascal, and that was primarily for MS-DOS. It was ported to a couple other platforms. But these interfaces sort of died with the platforms that they were created for because they just didn't last. You might hear people talk about this and call it computer-aided software engineering, or CASE for short, which is similar to like computer-aided design or CAD. There's CAD software, which is very successful. And then in the 1980s and the 1990s, there was just like this big ideological boom of object-oriented languages. These new languages, C++ and Java, put a lot of emphasis on expressing high-level abstractions, and they didn't get shipped with an interface. They were just a language specification. And then in the middle there, that's UML, which I think we can all agree is pretty gross, right? And then ever since then, new interfaces have been made to suit those existing languages. This is Visual Studio. This is primarily used for C++ development. There's also Eclipse, which is primarily for Java development, but that's kind of dead now, in my opinion. And so today we've ended up in a world where language specifications are created totally independently from development environments. And so to put it briefly, we're all just typing text documents with fancy editors. So now I want to talk about problems with modern textual programming and IDEs, and integrated development environments. I don't know if I said that yet. And these are just my own opinions, so just warning, potentially unpopular opinions ahead. So I've got three sections that I want to talk about here. First of all, variable and function naming. Not all variables need names, in my opinion. Sometimes the type of the data that you're working with is enough information to do work. So you got a couple examples. On the top there, that's a maximum function, and it takes two variables as input and returns one variable as an output. But the two input variables are entirely identical. It's symmetrical. It doesn't matter that they're named A and B specifically. So that's an example of like the type is all you need to know. And then this is a common programming pattern that I see a lot in my life, where on the bottom there you see I have a structure named myStruct, and then I'm instantiating it with a variable, and what do you name the variable? The exact same thing, and it's just redundant. You can't start your variable names with numbers. There's all kinds of restrictions. You can't use special characters. You might want to use parentheses, but that's reserved for function calling and that sort of thing. There's no consistent standard for how you make variable names with spaces in them. So like you can do snake case or camel case, but ultimately what you really want to do is you just want to type a phrase. And then also not displayed in the picture there, there's just this constant fear of using a variable name that you've already used and then like breaking your program or like getting a silent failure or something like that. You're always also thinking about variable name length. So like if your variable name is too short, it's nonsense and nobody knows what it means. And if it's too long, it just runs off the screen, right? Not only that, but editors can help a little bit with this these days with IntelliSense. But you need to remember function names, and not only that, but all of the arguments and the order that they come in and the return values. And if you don't memorize these things, you need to constantly refer to the documentation, and sometimes that's in a separate application, so it's a little bit of a mess. And then finally for this section, typos, of course. So like the most egregious case is this, like in Python, where you don't necessarily declare your variables ahead of time, and you can make a typo, and your compiler or your interface just doesn't tell you that there's a problem. Ideally, in the best case, you get a compile error, but in the worst case, you just get bugs that you don't know how to track down. So section number 2 here, text is inherently linear, which is a little bit of a problem when you're trying to express ideas that are not linear. So first of all, this is a cheat sheet for how to use VI. And I'm not saying that VI users are wrong for using VI, but it is a learning curve. And navigating linear code with a keyboard is difficult. And like this isn't even the whole thing, right? Like you've got different modes and stuff. And so, it's hard. It's difficult to get into. Also, like conventional formatting just leaves a whole bunch of dead space on the right side of the screen. And it's not even consistent. Your lines can be longer or shorter. And Sometimes you got to scroll left and right. Control flow and scope can get really confusing if you have like nested things, like nested loops or if statements or stuff like that. Like looking at this, you don't even know like what this return statement is talking about. You'd have to scroll up to see what it's going to return from. The go-to keyword, which is in some languages, is useful, like genuinely useful in some situations, like breaking out of nested loops or like consistent return expressions, but it's frowned upon because it breaks structure. And commenting out code can be awkward. Like if you just want to get rid of a variable, like it's all mixed in with the syntax, so you can't separate it. And if you just want to like see what your program does without a variable, like you gotta like go through the code and think about every single piece of syntax. Oh, and then also nested comments. I don't know if anybody else experiences this, but like I have not had a programming language where you can put a multi-line comment inside of another multi-line comment. It always breaks. And then of course, like current IDEs are just spending a lot of time just indexing the code that you're writing. And it's not even perfect. Like it bugs out. Like it doesn't recognize a variable that's in another file or something. And then finally, for this section, dealing with includes and imports is something I would personally just rather never deal with. And like most languages force you to do this hierarchical structure of like this depends on this, depends on this. But for some programs, you need to have cyclical dependencies. So yeah, that's just a problem that we don't have to deal with ideally. Okay, and so the final section here I want to talk about is readability. You shouldn't have to alter the functionality of your code to make it easier to read. In fact, readable code is an oxymoron, and I don't think most people realize that. Like if you look up the definition of code on Google, this is what it gives you. It says it's a system of words, letters, figures, for the purposes of secrecy. You're not supposed to read it, right? And the second definition is program instructions. So I just think that's funny. Functions with a lot of arguments and return values are discouraged. This is the same function I was showing you on that other slide. This comes from the Windows API. This is a function you'll call to like create a window, very basic. And it gives you a lot of options. It gives you like, what do you want to call the window? What do you want to put in the title bar? What's the parent window? All of these things, they're very useful, but functions with a lot of arguments are discouraged because it takes up the full screen. And then also, like, I'm sure everybody's experienced this. You're reading a static piece of text on the screen, and you, as the programmer, have to just like sit there and think about, okay, how is this actually behaving? Like you're using your imagination when the computer is right there and can do something for you. So we end up looking like that guy a lot. And then, of course, as the functions get longer and longer, large functions can be very difficult to mentally model. And then if your function gets long enough, there's this temptation to like reorganize things, put some variable declarations together, move them up, that sort of thing. But that's like a bad habit. That's an anti-pattern because there's a danger of altering the functionality of your code. You can't just move pieces of functionality around without affecting things. And you remember when I was talking about the history, Fortran, people were creating diagrams back then to explain how their code works. And we still use diagrams, and it's preferable to actually reading code a lot of the time, which is like, that should be a hint that the thing that we're working with is not actually that great to work with. Metaprogramming, so generics or templates, as you would call them in C++, they're difficult to understand and easy to screw up. So like on the top there, you've got a square macro, and it looks very simple. It's just taking the variable x, multiplying it by itself. That'll give you the square. But when you use that macro, basically it expands out into more code. And if you don't put the parentheses around what you want to be squared here, you end up with the totally wrong result. It's not a plus 1 in parentheses multiplied by itself. it's a plus 1 times a plus 1. And then here's a template example. So it wants to take this variable and multiply it by 2, but if you pass it the wrong type of data, it's not going to know what to do. So easy to mess that stuff up. This is a big one, in my opinion. The order of operations in linear code. Like, I wasn't sure whether to put this in the linear code segment or this section, but code doesn't execute left to right. It starts in the middle. It's going to start with that isValid function, and then it's going to go over and execute the length function, and it's going to compare if it's greater than 1. And it just, execution is jumping all around this line of code. And so if you're given like a line number by your compiler of something to go fix, that line number is not enough information to understand the state of execution. And then lastly here, this paralyzes me. I see error messages like this, and I don't know what to do. My brain just shuts down. And this is, I think, a direct product of the code being text, because the error messages just want to take the code and put it into the error message. So it's very unhelpful. So that's a lot to consider, right? You might be thinking, like, these are problems maybe with the user, not the environment. Or you might be thinking, like, we have best practices to sort of get around these issues. And some editors can address some of these issues, but none of them address all of these problems, right? But computers can handle these problems for us. Modern computers allow programming to be more interactive and more intuitive. And I think it's like perhaps the biggest problem with programming today is that code is not entirely managed by the IDE. The IDE is like trying to manage the code while there is a human just like typing in the text and screwing it up as you go, right? And so it's like it's putting friction on both the IDE's ability to manage the code and the programmer's ability to express ideas. So I'm going to run through some examples of how other industries have already found ways to reimagine how programming is done. There's this old piece of software called HyperCard, and it was used to create a game called Myst. And all it is really is slideshow software. Like, you literally make slides, and you can make areas on the slides where you can click, and there was a programming environment built in, and it was really good for visual programming. It's not just for artists, though. This is a piece of software called LabVIEW, and this is used for for science, really, for like lab equipment. And you can program like how you're monitoring your lab equipment, show visuals of how it's operating and that sort of thing. Blender is a really good example, I think. So like artists, 3D artists, generate geometry and they render colors programmatically. And they do that through this node graph interface at the bottom here. So like you have pieces of functionality that are nodes and you link them together. Unreal Engine has a very similar interface. It's another node graph interface. Game developers, they program game logic and they build shaders. This is a piece of software called Maya, which is like used in movies and games. Artists create procedurally generated like photorealistic particle effects. And that's another node graph right there. And this is FL Studio. Even it has a node graph editor where you can like mix and filter and synthesize audio. So like node graphs are like a really common way to do programming for what are traditionally non-programmers. And really there's way too many examples to mention. Like there's all kinds of programming interfaces like this out there in the world right now, and nobody thinks of it as like real engineering. And I think this is sort of what Linus Torvalds is kind of getting at when he says like good programmers worry about the data structures and their relationships. They don't worry about the code necessarily. So you could sort of imagine an interface that combines all of these, all of the features of these different visual interfaces into one general purpose interface. And then finally, I've got a couple of edge case things. So Minecraft, of course, has redstone, and a lot of kids are getting into computers through that. And then Microsoft Excel, you might not think of it like this, but like this is a real visual programming interface. You're taking pieces of data, transforming them, combining them. And so really, programming has been made exciting and approachable for everyone except for software engineers. Attitudes about visual programming are often negative. Maybe not this room, because the show of hands at the beginning was fairly open-minded. Some people think it's not intended for professional use. It's just for education, or they might think it's just artistic. It's not really for engineering. And sometimes they think it's domain specific. It's something that you put in an application for another thing, and it's not something that can stand on its own for like a general purpose programming language. But with all of that in mind, I had some of my own goals for a better programming experience. So for one, I want my experience to be general purpose. I want you to be able to do anything with it, not just create art or whatever. I want it to be portable. I want you to be able to create software on one machine and take it and put it on another platform and have it run. It would be nice to compile it to native binaries so that it's performant. You don't have to have like a virtual machine. I want the users to have precise control over exactly what machine code is produced. And I want it, most of all, to be discoverable, simple, and intuitive so that it's educational. So like somebody can look at it, see it, play with it, and understand it. So now it's demo time, baby. So this is not like a fully functional programming interface yet. There's some smoke and mirrors, but you will be able to get the idea. So I'm gonna have to get out of the PowerPoint. There we go. So we'll be looking at the console every now and then because it's going to print stuff out. So this is the interface. This is an application that I made with Python and the Qt framework. So this is an example of a programming interface that you might use instead of text. There's two connected diagrams that explain entirely what your program is doing. On the top there, that's a node graph. We'll be adding nodes and linking them together, and it shows the flow of data. And on the bottom there, there's going to be a flow chart, and that is going to show you the flow of execution. It's sort of like a timeline. So we're going to make a function that takes two inputs and produces one output. We're going to make a maximum function. I've already named it up there. In order to do this, first we need to define our inputs and outputs over here on the side. So two inputs and one output. And you can see already a node has appeared that provides our inputs. Now, over here we can specify the names of our arguments. So like if I typed in like apples, like you can see it updating. So that's pretty cool. But you don't have to name your variables immediately like you have to do in text. You can do it whenever you want. You can do it now or later or never. So you can also change the data types that you're working with. So I've got 4 primitive data types. And if I change this, you can see that the color of this little nodule on the side here changed. And that's because visually, the data types are going to have distinct colors, so you can't accidentally take an integer and put it into a Boolean or whatever. I'm going to switch that back. And then over here, this is pretty cool. I added a comment system. So if I wanted to have like a description, anybody got a fun description to put in here? Cool placeholder, I like it. And then if we hover over this field here, it's a cool placeholder. So I'll just drag that over there, and I'm going to drag in the project browser. So this here, this is the maximum function that we are working in. And inside of a function, you can find its implementations. We have one implementation called default. So what we're going to do is we're going to use another function inside of this function. So I've got a little humble library of functions to pull from here. And we are going to first compare two numbers. So we're going to see if the first number is greater than the second number. Okay, so a lot is happening right now, right? We've got things happening both in the flowchart and the node graph. As you can see, as I'm hovering over the node here, it's highlighting the flowchart element that is linked to it, and similar things for the links between the nodes. The links are things that run. They carry data from one node to another. So it's going to load the first argument into A, and then the second argument into B, and then it is going to run this function. And in fact, if we step through this using the little VCR controls that I've added, you can see, and it has sound, so that's fun. So it has brought 0 into 0, so like that's pretty boring, right? So let's add a number. Let's add 10. So it'll take 10, put it into there, right? Very visual, very intuitive. So now that we've had this comparison, we have one output out of this function, which is a Boolean. And we're going to, sorry, I'm going to use the mouse. I'm more familiar with this. This is a prototype, by the way. We want to pull this Boolean value into an if statement. So if I right click, it gives us some expressions that we commonly use in programming. I'm going to add an if expression. And I'm going to take this and put it in here. Oh, and it looks like I've screwed up my flowchart, so I'm going to fix that real fast. Where's the delete key on this keyboard? There it is. Got it. All right. Let's try this one more time. A into A, B into B. And we've actually, this is interesting. So we've got separate flows in our flowchart here. And if I want to correct this, all I have to do is drag the end of this line of steps onto the if statement, and it's going to put it in order for me. So back to where we were. There we go. So we've got a branching path in our flowchart now. So if this is true, if A is greater than B, what we want to do is we want to output A, right? So I'm going to add a return expression, and I'm going to take A, drag it into there. And on the false path, I'm going to add another return expression, take B, drag it into there. And now we have a program that actually does something that can actually run. So I'm going to put in another number here as input. And as we step through this, we can see that A goes into A, B goes into B. And you can see the flow of data and the flow of execution at the same time in a way that you can't normally in a debugger for text programming, right? And so it takes the true path because A is greater than B, and it's going to load that into the return expression. And then our program is done. If I try to do any more, it's not going to let me. So that's a pretty simple example of how you would do programming in this visual interface. So now that we have a function built out, let's use it in another function. So I'm going to create a new function here. It doesn't matter what name it is. But I'm going to pull this maximum function that we just created into here. And you can see it has the two inputs and the output like we specified. And I'll put in two different numbers, 42, 300. And I'm going to print out the result. So I've got a print integer function here I'm going to use. And need to correct the flowchart. There we go. And return. And if we click play on this, it's going to run through it automatically. All right, and if we check the console, there's a whole bunch of errors. It's still a prototype. There's 300. That's the right answer. So we can use it more than once, in fact. So I can take another maximum function, find the maximum of 3 values. So like if I add 24 there and feed this into here, rearrange, and print integer. Uh-oh, got a bug. But anyway, you get the idea. You can string together nodes with links and create programs. I was going to start out by showing you Hello World, but as you can see, that's pretty boring. It just literally is one node and then a return. I've got another example here, which is a sum of digits. This will show off how programs can loop. So you can see here that in the flowchart, there is this big dashed line arrow that goes from the end all the way back to the beginning. So it's going to run in a loop. So when we put in a number, this is a sum of digits function. So 2 plus 3 plus 1 is going to be 6. And if it's going too slow for my taste, I can speed it up. 6. I've also got switch statements. So this is an example of that. I don't have enumerations, so this is going to be a little bit more confusing than what it would normally be in text. But you can see it has 3 inputs, A and B. It's going to do some math operation, add, subtract, multiply, or divide, based on this third input, the operation. So if I wanted to do subtraction, I'll type in 1, and I'll just put in like, well, somebody give me numbers. Let's make this interactive. 37 and negative 9. Exciting. So that's 46. It does negative numbers correctly. This is a greatest common divisor function. This is a little more complicated looking. But if I put in like 3 and 9, the greatest common divisor, if we let it play out, is 3. Let's get some really big numbers. Somebody give me some big numbers. Okay, maybe a little bit smaller. All right. And another number? 455. All right, we'll see if there's a greatest common divisor. So it's not implemented because I didn't have time before the demo, but if you were to click the skip to the end button, the idea is that it would just run as fast as possible because it would be machine code. This is not yet machine code. This is just, a Python interface. All right, so that was 7. It had a greatest common divisor. That wasn't 1. That's pretty cool. So I also want to show off another feature here, which is you may have noticed there's like backstepping, right? You can step backwards, and it resets the state of the program as it goes. And it's like, it baffles me that debuggers don't do this by default, right? Like, it just seems so simple. And if we rewind it, you can backstep automatically, and you can watch it. You can watch it go through the flowchart backwards. You can watch the data flow backwards. And interestingly, if we go forwards again, as it runs, you can see the variables updating. Whereas like normal debuggers, you have to pause and then inspect, right? But in a better interface, you can pause at any time. You can play forwards, play backwards, and really play with the computer. Another thing I want to show you is recursion. So this function finds Fibonacci numbers. It's got 2 implementations, which we haven't seen yet. I'm going to look at the default implementation, which is the recursive one. So if we want to find the 5th Fibonacci number, for example, what it's going to do is it's going to step through. As we can sort of highlight our steps in the flowchart, you can see where the data is going to flow before you even run the program. And so if it's false, if it's true, it's just going to return 0 or 1. Those are the simple cases, right? If it's false, if it's greater than 1, it is going to go up on this path, subtract 1, subtract 2, and find the Fibonacci numbers of each of those subtractions. So it's a function calling itself. It's recursive. So if I let that play, oops, that's still stuck on the other one, so I'll stop that. There we go. So you can see it get to this step in the flowchart, and then it jumps back to the beginning because it's going deeper into the stack, right? And then once it comes out of that part of the stack, it continues where it left off in the flowchart. So what's the 5th Fibonacci number, you wonder? It's 5. So my girlfriend, who is sitting in the front row, who is not really a programmer, she's just sort of a beginner, she pointed out to me, like, this is slow, right? This is a lazy implementation for finding Fibonacci numbers. A better way would be to do it iteratively, to go forward through the sequence of Fibonacci numbers. That's faster. So that's why I have this optimized implementation here. Now, you can have different implementations for different levels of optimization, or you could also have different implementations for different platforms. As long as the inputs and outputs match, that's all that matters in this interface. So that finds the 0th Fibonacci number, my bad. If we were to try, to find like the 10th Fibonacci number, that would take forever in the other implementation. But in this implementation, 55. So that's fun. Now, I want to go back to the PowerPoint for just a second here. You guys recognize this function? You recognize what this is going to do when I run this? That's FizzBuzz, of course, right? It prints out numbers starting at 1, accumulating 1 every time. If it's divisible by 3, it prints out fizz. If it's divisible by 5, it prints out buzz. And if it's divisible by both, it prints out FizzBuzz. And so I've implemented FizzBuzz here. This is what it looks like. And so you can see 4 diverging paths here. You've got if not divisible by 3 and not divisible by 5, it prints out the integer. If it is divisible by 5 alone, it prints out buzz, as you can see when I highlight. Divisible by 3 alone, prints out fizz. Divisible by both, prints out FizzBuzz. And if we look at the console, you can see it run. Whoops, I closed the demo. We'll just open that back up. We won't have our maximum function, our beautiful maximum function that we created together, but will live. So finally, I just want to show you some things that don't run in this interface right now, but these are things you could conceivably do with a visual programming interface that would be better than text. So remember that Windows create window function? This is what it looks like in a visual interface. And you can easily see all of the types of data and all of the names of the arguments in a way that you can't in text, right? You don't type the name of the argument before you give it the value when you write a function in text. And you can easily see the outputs and what type of data those are. And then not only that, it's not taking up space in a linear form of code. Like you can have other nodes in this interface, up, down, left, or right of it. It doesn't matter. Here's an example of how converting a data structure from one format to another might look like. So this function takes 3 floating point numbers, converts them all to integers, and outputs that. And it's very easy to see like how each thing gets transformed. And then finally, if you're interested in AI, this is what making a neural network might look like. You could use the mouse to drag and drop pieces of the neural network around and actually play with it and visualize it and understand it in a way that you can't with text. So that's pretty much not all of my ideas about how visual programming can be better, but it gives you the gist of the idea. I've got some other features in mind for future work. Oops. Well, I'll just go back to the other representation. So you can have nodes that are something you can click on and like play with, like a color editor like that. And you can have nodes that show you pictures of things that like are different ways of visualizing data than just numbers. And then also this is a feature that a friend of mine named Jacob keeps requesting, where you can organize your links by putting dots in the middle of them and branching them out. So Jacob, I am working on that. And then finally, these are some talks that I think are worth seeing. Brett Victor, he's a user experience designer. He had this great talk about the future of programming, but he's like a nerdy engineer from the 70s, and so he like carries this persona into the presentation as if he was still in the 70s. I'm going to leave this up in case anybody wants to, scan this and watch one of these talks later. Jonathan Blow, he's a game developer. He has this talk called Video Games and the Future of Education. It's not as much about video games, really. That's just the title. He talks about how humans learn things and how we can cater to that with more than just words. And then Dave Thomas, if you know of the phrase rubber ducking, this is the guy that created that phrase. He's one of two guys that wrote a book that phrase came from. He has this talk, The Legacy of Simula 67, where he talks about how ideas are structured in computing. Because Simula is where most of the ideas of object-oriented programming came from, like classes and inheritance. So all very good talks, and I recommend you watching at least one of these. So, before I take your questions, I have a question for you, which is, do you think that there is a better interface for programming than text? Show of hands. There's more hands than before, I'll take it. All right, so if you disagree, if you're still solidly in no, text is better, raise your hand. Ah, okay, a couple of guys. I'm not sure if you guys raised your hands before, which is concerning. And anybody still uncertain? Okay, I've convinced some people. All right. Yeah, any questions? In the back.
All right, I'll bring the mic over. So you made an interesting assertion in your presentation about debugging. You showed off the feature of going backwards and how your IDE is keeping state. But as we all know, when a program actually crashes, the CPU doesn't keep track of this state. So how's this visual programming editor going to solve that problem for you to actually go backwards and actually debug the issue?
So ideally in this interface that I created, when your program crashes, it doesn't lose track of it. Ideally, the interface should keep all of that for you. I don't think that's an impossible problem to solve. I think you could, I think I could create a feature where if your program crashes, you can just step backwards. Unless you're saying the interface itself crashes, in which case.
I'm talking about you're not going to deploy your IDE with the program that you create. You're going to deploy that separately to users, right?
Right.
So when that program crashes, you're not going to have that information. So how are you going to be able to tie that back to your IDE at a later point?
So logs are always helpful, right? And I think program output is never going away. You will always, if you're writing something for production and it's going to exist outside of the interface, you will have to add logs to be able to understand what your program was doing when it crashed. I do have some interesting ideas about how you could make a remote debugger that could capture a lot of the state of a production application, and then you could replay that on your machine. I think that's an untapped potential for programming interfaces. Any other questions?
Hi, so I was looking at your FizzBang example, both in the new IDE and in the one you had on the screen because you were presenting.
Thank you.
I was in tune with that. But one thing I did notice is that, one, it took up a lot more space in the new IDE. And two, I feel like maybe it's just because this is a new technology and I haven't worked with it before, but I feel like it would take a long time to actually make a function in the new environment. Is there a concern about the speed at which you would be able to produce code?
So I think that's a really good question. I was kind of hoping somebody would ask something along these lines. So first of all, I think the speed of writing a program from scratch is just one factor of doing programming, in my opinion. We spend probably a lot more time just trying to understand what a program is doing when you're looking at it, right? And that's really what I optimized the interface for. But that being said, I want to add like shortcuts, things that you can do with the keyboard or with the mouse that allow you to do things quicker than just always dragging and dropping stuff. Because like that's the ideal, right? Like there's just no barrier between you and the computer and like getting your ideas into the computer. Any other questions?
I had a question on, so I like the way the interface looks. I like how it's very friendly to the user to be able to understand what they're doing, going to and from a function. But my question is how resource intensive is it, right? So if you're gonna have to render, like these are very small examples in this case, and I know it's still a prototype, but when you scale it on a much larger scale, say like a inventory system for like an ERP for a manufacturing center, right? How are we going to make sure that if we're going to use something like this, would it be better for somebody to build in an IDE like this, or is text-based still better in that scenario?
Well, I believe that like computers can be like they can do amazing things, right? Like Elden Ring, for example, like that is a miraculous game that couldn't have existed in the 70s, but we're still working with 70s technology, text editors, and like this computer, this laptop didn't struggle with using this interface, and it could my interface could easily be optimized to be faster. So I am not at all concerned about the performance implications of an editor that has a lot of features. I mean, I look at Visual Studio and it crashes all the time because it runs out of memory and stuff. And it's like, we can do better than that and we can make it visual, in my opinion.
Just one more thing to note. I just wanted to point out that we lost our vertical, we got horizontal space on where we were seeing it for how it's functioning, but we didn't get our vertical space. I think we can zoom out is what you're showing there, but
yeah, for sure.
I do like that. I do like being able to see it on a much better scale in that case.
Yeah, and I could easily change the interface so that the flowchart and the data are side by side, and both of them flow down instead, whatever,
You talked briefly You talked briefly about portability. How does exporting it look like?
So let me restart it here. My idea is that like this should be a simple interface like a piece of Adobe software because I have a background in video technology. And like I have a mock of a menu here where it's like you can build or you can build and run and it just outputs an executable file. And it's just that simple. Like my idea is like make it as user-friendly as possible. Like we know what computers are and what they can do as programmers, so just take us directly to the easiest thing, the thing that we're doing all the time. That's like a UX thing, in my opinion. Any other questions? In the front? Okay, sorry, I'm making you run all over the place.
Very well. I think you did a good presentation. I'm curious if there's a universe where sometime in the future I can write Python code and have it interpolated, whatever words, between this format and text, in the sense that it would be fairly easy to, you gave examples of text and then your version, text and then your version. Maybe you could write a system that goes between them and therefore allows you to modularize your code. Speaking of like implementation stuff, how about have little modules that are already written in hard code that are just called by this thing? You know what they do. You don't need the inside of those things, but you do need the inside of the big parts. Cue the Linus quote about like the overall control flow, data structures. That's what you're trying to get at. Do you plan on making a system like that?
So that thought occurred to me too, and it's occurred to a lot of people that I showed this to before this presentation. In my opinion, it's like, why have that extra layer of like compiling the to text and then compiling to machine code after that? But I can see like there being a use case for like you've got a code base that you want to transform into this visual nature, or you decide that this is not for you and you want to go back to text. Like I can understand that that would be a good feature to have. It is not a high priority for me, though, for this project.
So I used to use a Visual IDE to develop Android apps, and the issue I eventually ran into was there were not enough blocks to do everything I needed to do, so I ended up having to resort to injecting text-based code in to accomplish everything I wanted to accomplish. What do you do with an IDE like this when you run out of blocks and visual elements?
I think that's a great question because I mentioned during the talk, like I want the user, the programmer, to be able to exactly define like what machine code is produced. And I think the way to do that is like, if you have a library like this, if you were to drop it down and look at the implementation, it would show you in a visual interface the machine code. Like each instruction would be a node and it would have its inputs and its outputs, and you could link them together that way. And it's a way of working in assembly that doesn't feel like working in assembly. Like that was my idea, at least, is that you could have access to everything the computer offers.
I was thinking while listening to you present that a lot of the things that I'm both seeing and hearing feel like Microsoft Logic apps and existing programs that are out there that are accomplishing the low code, no code workflow style. Do you see this as being intended to compete that is in a way that is almost taking the code out of coding for the sake of people who don't want to learn the actual linguistic components of it?
I think it's a great question. I think that at the end of the day, if you create a piece of software that is performant and does what you want, like you are doing real programming, and like I don't think this is really any different than text programming. Like it's you don't have as many like abstractions maybe in this interface that I showed today, but it is immediately approachable, and very quickly it becomes a powerful tool, I think, to somebody who is not familiar with like programming language syntax. Whereas like in a text environment, you open up your text editor and it's like you don't really know the tools that you have to work with. Maybe IntelliSense will help you a little bit, but when you have a visual interface of like options to choose from, that is, in my opinion, like a better starting point, and you can do all of the same things with it, if not more things, if you have access to the machine code instructions, which you don't normally in like a text programming language, in my opinion.
I have a two-part question, if I may. I wanted to ask, what initially turned you on to doing this project? And then, as a little follow-up there, if you could expound on your choice to start with these like really simple, close to machine code primitives for your proof of concept.
Could you repeat the second part of that question?
Oh yeah, if you could expound on a little bit why you chose to go with these primitives. Like
These
primitive
primitives,
data types, primitive functions, like
oh,
core computer science logical stuff.
well, I mean, for example, these data type primitives, like this is just meant to give you an idea of like, these are just a few examples of primitive data types, but you could add more. You could add like a bit data type that only takes up one bit of information instead of a bool, which may take up a character or whatever. Like there's room for flexibility in designing this user interface. Does that answer your question, or is it not really getting at it?
For the viewers at home. Yeah, that does answer the second part of the question.
Right.
But then the first part there is really what turned you on to the idea of doing this in the first place?
Yeah, so originally in October, I was like just sitting on my couch and I was thinking about, programming philosophy, whatever. And I came up with this notion of like, there are node graph interfaces everywhere. Like, as I was saying in the presentation, you got Blender, you got Maya. there's so many others that I didn't mention that are just programming interfaces for non-programmers. And I'm like, why don't you just make that an interface for general programming? And originally my idea was like, oh, you can make a node and type a sentence and have an AI generate how it's implemented. But then I was like, oh wait, no, you could actually make this like a real programming interface that a human could use. A human could go in and they could make a neural network like this, define the inputs and outputs, make a neural network, and do it all without having to resort to, AI prompting or anything like that. So like, as soon as my mind went to that place, I was like, okay, this is just an entirely new way of programming that people don't really take seriously as software engineering. So that's what led me to create this whole interface.
In this kind of interface, what is your future for showing debugging messages for errors and other kind of problems that you might run into? I know that you saw it in the console here, but I don't know if that's fully implemented, and I'm kind of curious to see what you would want to output that as.
I think that like this is, clearly I keep saying this is just a prototype. And you could easily add a console anywhere in this interface. You could add it, below the flowchart maybe, or you could have like a menu option where it's like, show me the console and it opens in a new window. I think the sky's the limit for like where you place things. Whatever feels the most intuitive for a new user, I think is what I would want to optimize for. Good question, I think. Oh, okay.
Here, let me come behind you. Sorry. Hi, thanks. I think we've gotten a good understanding of how this works at the functional level. What is your vision for this IDE when it comes to putting multiple functions together and giving a higher level, more abstract view of how those functions play together in a larger application that doesn't obfuscate the full application's purpose with all the minutia of the individual logic, essentially, of each function? So how can I pull back to the 5,000-foot view of a full application in this IDE and get an understanding of the different classes that might need to interact together above the function level?
Right. Well, for one, I want to point out, like, my idea for this is that it is definitely not supposed to be object-oriented. I want this to be like a functional programming language, sort of. And so in that way, I haven't added anything like classes or inheritance or anything like that. At the end of the day, I just want to show the user these are the instructions that the computer is executing. This is, these are the possible paths it can go down. And if you want to drill down into how each of these functional elements work, you can just open up that implementation. That's my idea.
This seems like a really cool tool for those functional implementations, because obviously it goes through all the individual steps. Debugging specifics is very easy, but the problem is that in the amount of time that it's taken us to get to this visual editor, code editors in general, just the power of text has gotten so voluminous in so many ways. We're talking about like, this doesn't support any kind of dynamic typecasting by the look of it. This doesn't support any like making functions or classes or all these bits and pieces we've come up with, and that doesn't even scratch the surface of what you can do with web stuff, what you can do with live stuff. Like debugging servers with this, it would be a nightmare. You'd have to make a dump file that dumps everything. It would be a nightmare beyond a nightmare. This is really cool. How am I going to use it in my day-to-day programming experience, where very often I need to do things outside of the purely functional programming world?
Can I get an example of like, just a very basic example of like something that you would want to do that this does not provide?
I suppose there's people better qualified to say this than me, since I don't do a lot of non-functional programming, but like this interface component in this website is not displaying in this location properly. Like, it's going to HTML.
Right.
And that HTML is wrong, and something's wrong in the interim. What's the problem?
I just think that comes down to, finding which variable is wrong in the interface, and then just maybe stepping backwards to see how it got to that state. Does that answer the question?
I think I hope someone else has a better example because maybe people know what I'm talking about here. Debugging servers is probably a good example in the sense that there's lots of data flying around. Like, what if I wanted to look at a giant multi-dimensional array? You're talking about like neural networks. How in the world are you going to display that?
Well, I mean, hopefully a neural network in this kind of interface would look like this. But as for arrays, I haven't implemented anything like arrays of data yet. I mean, I have ideas about how to display that visually. I mean, I have ideas for all kinds of ways of visualizing data in a way that is better than just looking at, local variables in a text debugger,
Yeah, like there's some program that's so crazy that they rewrite their own instructions, like as memory. Like how could you possibly? There's just a lot of work to do if you're going to go and make visual programming of all of the subfields of all of the things that code can do. Text is simple because the execution is also linear. So it's kind of you have to fight that to make it work.
You kind of lost me. Are you saying text is better because execution is linear?
I'm trying to figure out how to use this because it seems really cool and it's got my gears turning in a way that I like.
Yeah.
But I can't figure out how to use it.
Well, I mean, hopefully that's something I can work on, I hope for this to be something that is easily approachable, something that you can easily just step through the instructions, see exactly what the computer is doing at a low level, and be able to understand what's going on. A question?
Well, yeah, first of all, just say this is really cool.
Thank you.
I'm really impressed with what you built.
Yeah.
I mean, just to build what you've created here is pretty impressive stuff.
I
right?
appreciate that.
Okay. And I guess from that, I would just say, what are you most excited about building first out of what you've created here? What are you looking forward to? What are you thinking? What was the reasoning behind this? Because there must be something that you're thinking, I can create this out of this. What's a real world example that you're thinking about creating?
Well, of course, like I said before, the initial idea was make it an easy interface to use for building neural networks. But it goes beyond that because actual programming logic is simpler than all of these connections that you see on the screen right now. And it eventually turned into an idea about this is a way that we can play with our computers that we have not really done before. When Microsoft introduced Visual Basic, that got a lot of people into programming that weren't into it before because it was a simple language. And I think a visual language is potentially a more intuitive way to understand how a system works. Yeah.
So, to play off that HTML example earlier, I wanted to ask, what's the total file size of the demo you have as it exists right now? And do you think it's lightweight enough that as a debugging in another system, you could output an instance of this Visual IDE for someone to run on their machine when they're debugging it?
Whoa, could you repeat that second part? That sounded wild.
Right, so if it's lightweight enough, and if you had an authorization problem, you could just lock it behind some web service that requires authorization. But in the debugging, what if you just attached a file that was the Visual IDE with the program in it, with its execution history? And so you wouldn't have to have it installed, totally super portable. I just think that'd be a really crazy and interesting way to do it. If it's lightweight enough.
I agree. I want to talk to you at 417 Tap House.
Yeah, absolutely.
Yeah. All right.
I got a couple quick questions for you.
Yeah.
I've been over here thinking about this.
Yeah.
There's two things that I have two questions and a statement for anyone else who's interested in this because we have been going along and we should finish the conversation.
Yeah.
At 417. So one thing in particular about text-based programming languages that I think are nailed today, in my opinion, is version control. Git and text-based, it works really, really well. And the simple answer might be you turn this into Figma with real-time multiplayer type functionality where you see other people's cursors moving around. But I don't know if that's even the right answer, but I'm curious if you've thought at all about version control.
I have.
Okay,
yes.
cool.
So, I just want to show you for an example, like this is the project file. I'm gonna open it with Visual Studio Code. Ugh, text, right?
Gross.
So like you can do git version control on a text file. So like that's like an easy implementation. But I have been thinking like maybe there is a way for you to like do
See diffs in the editor or something?
Yeah, see diffs in the editor. So like if something goes away, then like it outlines it in red, or if something is new, it outlines it in green, or if it's modified, it outlines in yellow. Just like, you know.
And a way to handle conflicts too. That's like the
Right.
big thing as well.
Yeah. But
And
that's
the
like-
text-based one that you showed is like programming languages but worse.
Right.
So I think you would have to solve it there. The other thing, this is maybe more of a challenge than a question, but like to me, the ultimate test of something like this is, can you build the IDE with it?
Yeah, yeah.
like how most compilers are implemented in the language they compile. right?
Exactly,
So,
yeah.
Anyways,
So-
I feel like that's the next step.
So this is a prototype.
Right.
But that is something I've also thought about. It would be really cool because if you have access to the machine instructions, you could conceivably make this in the same language. So yeah, that's something I've thought about, and I think it's definitely possible. Yeah.
And the last comment that I had, and this is maybe a question for you and everyone. There's actually like a whole sub community around this. There's a podcast that I got very deep into, heavily inspired by the Brett Victor talks and those people. It's called The Future of Coding, I
Yeah.
believe.
Yeah.
You familiar with it?
I'm kinda. I haven't.
Okay, yeah, I'm like fully caught up except for 2 episodes. It's gone through a couple different hands, but they talk a lot about these ideas, and I would highly recommend that as a resource if this seems intriguing, because they go very, very deep.
Yeah, yeah.
So.
I'll need to watch that.
Cool.
Yeah.
All right. So with that, like I said, if you have more questions, let's go hang out at 417 Tap House. I got a couple closing slides, but let's give them a big round of applause, please.